Stanford University.
All right, well, welcome to Stanford CS193P. This is developing iOS applications, winter of 2017. And the only topic for today is a big one, core data, which is an object-oriented database. But before I dive into this, I'm actually going to revisit that demo we did last time just briefly because we ran out of time and so I wasn't able to show you the refresh control. Now I posted the code for it, so I'm not going to type all the code in here, but I'm just going to briefly show you how that refresh control worked, okay, in case you missed that. So here is the app we had from last time. By the way, I have modified our app here to change our request a little bit. If you remember this line of code from last time, it used to just have the query. But I've changed it to also filter out retweets. And I've also put on the safe filter, which hopefully will make it so that when I do these lookups, these Twitter lookups, we don't get stuff on the screen that, you know, this is a family show, so we don't want to see some of that stuff. So anyway, well, hopefully that'll work. So let's go back here and take a look at what this looks like. There's my simulator right here. So let's go ahead and search. Let's try Trump again and cross our fingers. All right, so yeah, I don't see anything too terrible there. Okay, so what we added was this UI where we can pull down, okay, and it adds more tweets. You see how it added a tweet there? We have this second pull right there. This was the first pull. And we pull down again, no tweets this time, okay? So each time we pull down, it's doing another Twitter fetch and may get more tweets depending if people are tweeting or not. So let's take a look at the code to do this. Again, I posted this code, but we'll just look at it. I'm not going to type it all in. We're just going to look at it real quick. First of all, let's talk about how do I get this UI where we pull down and it calls a method or whatever. So let's go to look in our storyboard. Oops. Yeah. All right, so here's our storyboard. And what I did was I just selected my table view controller and I went down here to this refreshing. See that refreshing choice? And I changed it from disabled to enabled. And when I set it to enabled, nothing changed here in the UI. You can't see any spinning thing. But over here in the document outline, it created this refresh control right here. And so I can control drag from the document outline just as I can through here. So all I did to make this work is I just brought up my controller right here. And here's the method I did it with right here. I just control dragged from the refresh control to this method called refresh. Okay, that's all I did to make that happen. And inside refresh, I just called that same method I had before, search for tweets, this one right here, the one that searched for tweets. And that used to look like this. I only changed one thing in here. Okay, it used to just get the Twitter request by looking at our search term up here. Remember this function? And all I did was added this, which says, if the last Twitter request has a newer version, then use that. But if it doesn't, then default back to doing Twitter requests the way we used to. The only other things I had to do was turn the refresh control off. You do that with end refreshing. So I just did that when I went back to the main queue here to give my results. I turned it off. I also turned it off if for some reason I couldn't get any request whatsoever. Okay, there was nothing in the search term field, and I couldn't get a newer version of my last request, so I just said, I'm just going to make sure that that thing is not spinning and spinning forever. Okay, I didn't want to get out of here with that. And the only other thing I had to do was up here, when the search text changes, someone types hashtag Stanford or something like that, I need to invalidate that last Twitter request so that it's not trying to get new versions of the previous one that I had. I wanted to do the new one. Okay, and the way that I made it so that we had these little titles right here, see these titles, 2, 3, 4, 5, I implemented another UI table view data source method, this one down here, okay, called title for header and section. I just put titles on the sections. Remember, each section is another poll from Twitter. And so I just had each title section be the count of things I had minus the section number. So the top one is section 0. So section 0 is going to show the number of polls that I've made. Tweets.count is how many polls I've made. And it's obviously going to decrement as the sections go down. Okay, and so that's what gave us this. And you can see that the longer we wait, obviously it pulls more information as tweets pile up. Okay, Let's go back to our slides. All right, here we go. So core data is this big framework inside of iOS for doing object-oriented databases. So let's talk a little bit about what that means. So when do you need a database? Well, you need a database when you have a large amount of data, and especially if you want to kind of make queries into that data and find out things about that data and the relationships between all the things in there. You really can't do that by like making a big dictionary or a big array and searching through it. You need a database. And so there's a lot of technologies for databases out there, but most of them are not object-oriented. So we have this framework that Apple provides called core data. It's this what we call an object-oriented database, but actually it's really not an object-oriented database on the underside, on the inside. It's only an object-oriented database on the outside, the side that you look at. Underneath, it's actually a relational database usually. Okay? Now, core data is designed to have any back end of storage. Okay, but its primary implementation is on top of SQL, which is a relational database. How many people know what SQL database is? Okay, almost all of you, good. So if we had to do databases in our iOS app using SQL, we'd be like, oh no, I have to learn this whole query language, and how am I going to do this? Not to worry, we don't have to know any SQL to use core data. No SQL whatsoever. We're just going to purely do this on the object side. So how does this work? How does core data work? Well, first we're going to create a visual mapping between things in our database and some objects that we're going to be able to program with in our object-oriented code that we like. And kind of roughly, it's, you know, the tables in the database are kind of going to be objects, and then the columns in the tables are kind of vars, but we don't even really care what it's doing there. What we're going to focus on is this visual map, this visual description, basically, of our schema. Okay, how many people know what the word schema means? Okay, so 2/3 of you. So schema is basically the description of what's in your database, not the contents of it, but how all its data types are and how they relate to each other, et cetera. So we're going to do all that graphically, okay? And this is what it looks like, okay? First, if I want to use core data in my app, I'm almost certainly going to want to click this button that says Use Core Data. We've seen it every time we've created an app, and we haven't clicked it so far, but now we are going to click it. And clicking Use Core Data there is going to create two things for us, this visual map and some code in your app delegate. And I'm going to talk about both of those things. Now, before I go to the next slide, notice that the name of this app is Core Data Example. That's just the name of the app that I typed in there. So when I create this app, clicking that Use Core Data on, you'll see that it created this file, core data example.xc data model D. Okay, so it shows the name of my app as it, and this is going to be our data model. All right, and so we'll talk about the app delegate code that Use Core Data also generated a little bit later. But right now we're going to focus on this data model file. All right, but before we even do that, what happens if you have an existing app and you did not click Use Core Data, and now you decided, hey, I want to add core data, like maybe smash tag. Assignment 5 comes out, and I tell you to add some core data to smash tag, and you're like, whoa, I can't go back and click Use Core Data, it's too late. So you're going to have to create this data model file using New File. So you just go to File, New File like this. You're not going to pick any of the things we've picked so far. You're going to scroll down to the section that says Core Data. And inside there, there's two things, data model and mapping model. And make sure you pick data model, because that's what you want to do here is create your data model, your schema, essentially, for your database. It's going to ask you what you want to call it. Now, you don't have to call this the same as the name of your application, like Use Core Data button does. You can call it anything you want. So here, just to be different, I've called it model. It's my model. And by the way, your core data is usually the model of a lot of MVCs. Okay, a lot of MVCs, their job is going to be to display the data in the database, and so this data model is actually the MVC model as well for a lot of MVCs. So I'll call this one model, and you can see it created model.xc data model D. So whether you get that file by doing Use Core Data, or whether you get it by creating it yourself, you're going to have this mapping file. Now, let me go back to that app delegate thing. I said that I was going to put some code in your app delegate. It's a very small amount of code, but I want to just show it to you right here. This is what it looks like. it just creates this one var right here, okay? Oh, by the way, yeah, if you didn't do use core data, of course you need this code in your app delegate. How are you going to get it? Just go create some dummy application, okay? Call it foo. It doesn't really matter what you call it. Click use core data when you create it, and then copy this code from that app delegate to here, okay? The code is identical from every app. The only difference between any of those things is this one string right here. You see that string? That's the name of that XE model D file. Data model D file. So with our core data example, this string would be core data example. When we went back and created it on our own with new file, of course we called it model. So just make sure this string matches the name of the string, or the name of the file, the XE model, data model D file. Okay, so that's what you need to do if you didn't do the use core data originally and you're going back and add it. So you just copy and paste it. It's only this one var really. It does provide another thing in your app delegate, which is a function called save context. It's a very simple little function. I'm going to show you how you could write it yourself. If you want to copy it in, you can. Also, I notice that they have application will terminate, which is this application app delegate method that gets called right before you get terminated, or you terminate it anyway. And they call save context. Well, it's kind of a good idea. Save context just saves your database. That's what save context does. All right, so this is how you can make up if you didn't do it. So anyway, you can see that the only thing in here is this lazy var persistent container. And I'm going to talk all about persistent container because that's the thing that essentially contains your database. All right. But let's go back and talk about the visual map, because we have to have a visual map before we can do anything in our database, because we have to have some things in our database, some objects and things like that. And core database stores things in this kind of very straightforward way. It looks very object-oriented in our code because in core data terms, it's storing entities, which look like classes to our code, attributes, which look like vars on our classes, and relationship, which just look like vars that point to other objects in the database, other entities, etc. And so we're going to use this, what I'm calling a storyboard. It's not, don't get confused, this is not a storyboard. Okay, you know what a storyboard is, your interface builder thing. But it's kind of like a storyboard, that's why it's in quotes, for databases. Okay, it's a graphical visual editor to create and describe all these entities, attributes, and relationships. Okay, that's what we're going to do here. So let's start by adding an entity. Very easy. We go down to this button on the bottom here called Add Entity. Okay, to add an entity. By the way, there's a couple other things in that. If you hold down on that button, you'll see Add Fetch Request and Add Configuration. I don't have time to talk about those, unfortunately, but especially Add Fetch Request is kind of a cool one. So if you can take what I teach you here and extend it by going and learn about that, that would be great. So when you click Add Entity, it creates a new entity called Entity, okay, because it doesn't know what name you want for it yet. And like I say, this is analogous to a class. Now in our code, we're going to see any instances of this entity as instances of a class called NS-managed object. So NS-managed object, super important in core data. It is the superclass or the class of everything that comes, all these entities that come out of the database. It's like the thing that represents them in our code, and we'll see all about that. So for my kind of slides here, what I'm going to do is create a database that would have stuff like we got from Twitter. So it's going to have tweets, and we're going to have Twitter users. Those are going to be two entities that we have. And you're going to see eventually we're going to have tweet and Twitter user classes in our code, and we're going to access vars and all that stuff. So I'm going to rename this entity that I added that was defaulted to entity. I'm going to rename it and call it tweet. Okay, so it's going to be the first entity that I'm creating in the database. Now, an entity can have attributes, those are kind of like vars, and relationships, like those are like vars that point to other entities. And I told you this fetch properties down at the bottom I'm not going to talk about. Very cool, but not going to talk about them, just time-wise. So let's go ahead and add some attributes to this entity. Real easy, you click this plus button. There's also an add attribute button. See it down in the lower right-hand corner there, but I'm going to click this little plus button right there under the section called attributes. And when I do that, it adds a new attribute called attribute. And I'm going to edit its name directly, just like I did the entity name. I'm going to change this to be text. So this is going to be our tweet's text. The 140 characters of the tweet is going to be this particular attribute. Now, notice as soon as I did that, I got an error, okay, in the corner there, this red error. And the reason for that is all attributes have to have a type. They can't just be undefined type like this one is. You see where it says the type is undefined. So we need to change that to be a type, and it's really easy. Right there where it says undefined, we're just going to mouse down. It's going to bring up a menu, and we can choose our type. Now, these are the types we have to choose from. A lot of different numeric types like 16-bit integer, 32-bit integer, etc. Doubles, floats. It can be a string, of course. A Boolean value, a date, which is going to look like a date in the date struct in our code, and binary data, which is going to look like the data struct inside our code. So these are going to map to very familiar data types that we see. There is that one at the bottom there, transformable, another thing I'm not going to talk about, but transformable allows you to store anything into the database by converting it to a data and then converting it back on the way out. And so if you pick transformable there, you're going to have to do some extra work to tell core data about that transformation. And that's what I don't really have time to tell you about. But just know that if you want to store something like a CG-rect, actually if I was going to store CG-rect, I might use the function. There's some function called something like ns string from CG-rect. It gives you a string, and then there's ns CG-rect from string or something like that. So I'd probably store it as a string. But if I had something more complicated than that, then I might use a transformable. All right, these attributes here are going to be accessed. We're going to get and set their values. Well, actually, we're not going to do this, but fundamentally, the way you do it is you have these two methods, value for key and set value for key. And I'll talk about how we're going to use that, but that's how we're going to set and get the values on an entity. Notice the arrow went away as soon as we gave this thing a type. So here I'm going to add some more attributes. Identifier, which is just some string that identifies the tweet, and then created, which was when it was tweeted. Notice I'm setting created's type here to be date, because it is a date, obviously, when the thing was created. Now, this is one way to look at our entities and attributes, this kind of table form, but we can actually look at it in graphical form as well. If you see down in the corner where it says editor style, if I click on the other button there, the one that looks a little more like a graph, then it shows me the same thing, but in this graphical form. It's even on graph paper. All right? And in this form right here, we can do all the things that we did in the other one. For example, I can still add entity here. So I'm going to add another entity for my Twitter user. This is people who tweet. And there it is. It called it entity again. That's the default. We'll set its name to be Twitter user. All right, so now we have two entities you see on there. What's kind of cool is as you drag these entities around, this kind of editor, this graphical editor, will automatically kind of keep them spaced apart from each other, which is kind of fun, especially since they're going to start having wires connecting them because they're going to have relationships to each other, as you're going to see in a moment. We can add attributes in this graphical style as well. You can edit those right in there just by double-click on them, change whatever you want. So here I've added the screen name. Now, of course, I got an error again because I didn't set the type of that screen name. So in this view, you set the types by bringing up the inspector. So you just bring up your normal inspector, attribute inspector, and here you can see it's inspecting screen name. It's got the name there. There's some other things in here like transient, indexed, optional. By the way, that optional doesn't mean this is optional like the Swift thing optional. This is optional like in SQL database terms, right? In relational database optional. So I'm not going to talk about any of the database stuff of it. You rarely need to set any of these properties right here. But you do need to set the type, okay? So we're not going to talk about that, but we have to set the type right here. And the screen name, of course, is a string. So I'm just going to change it to a string. So I'm going to add another attribute to the Twitter user. This one is the name. The person's actual name, not their @ handle, but their actual name. And so now we've built a couple of entities with a bunch of attributes on them, okay? And this is going to look like classes with vars in our code eventually. But what about relationships? Obviously, a tweet and a Twitter user have a relationship to each other. And to create relationships between things, we just control drag. This is our favorite gesture in Xcode, and we're using it again. Control drag to create a relationship between two things. And it actually doesn't matter which direction you control drag because you're creating kind of a bidirectional relationship. So here I did control drag, and it automatically created this relationship, which it called new relationship on both sides. Okay, and this relationship is essentially just going to be a var in our class, but the var's type is either going to be the type, if it's like a tweet, it's going to be a single one, or it could be an NS set if it's many of them. Like a Twitter user might have many tweets, and I'll talk about that in a moment. So from a tweet's perspective, this relationship to a Twitter user is the tweeter, the person who tweeted this tweet. So I'm going to change the name of this relationship on the tweet side to be tweeter instead of new relationship, which was the default. But on the, okay, so that's why I call it tweeter. On the other side, the Twitter user, from his perspective though, okay, the relationship to the tweet is the tweets that this Twitter user has tweeted, okay? It's not tweeter. This Twitter user is the tweeter, so he would never call this relationship tweeter. He's going to call this relationship tweets because this is the tweets. Now notice that's plural, okay? We'll talk about that in a second. Notice that when we do this, Xcode tracks, if I'm inspecting the tweets relationship there on the Twitter user side, it knows the inverse. It knows that tweeter goes the opposite direction. There's always going to be an inverse relationship. So let's talk about that tweets being a plural, right? So a tweet can only have one tweeter. Only one person can have tweeted it. But a Twitter user could tweet thousands of tweets, okay? And so that's a little different kind of relationship. So how do we specify that? We call the tweets relationship a too many relationship because obviously the Twitter user can have many tweets. So that's called too many in database parlance. And you set that right in the inspector. So you just click on that tweets and you go over here to where it says type, and instead of having it be too one, you're going to change it to be too many. Okay, so now it's a too many relationship right there. You can see that it's changed a little bit, and we'll show that in a second. But the type of this relationship now on the tweet side is still type NS managed object because it points to another entity in the database, and we know that the objects in the database are represented by an NS managed object. So that's going to be the type of that var, although we're eventually going to make it even better than that. But on the other side, though, the type of that var is NS set of NS managed object, okay? Now, NS set, there is a Swift struct called set, okay? It's a generic type. It's just like array where you have to say what's in the array. Same thing with a set. You have to say what's in it. NS set is kind of an older Objective-C kind of set. It's not generic. It's untyped. The things in an NS set are any, which we kind of need a little bit here because we really don't know what kinds of things are in there. However, in your code, you can cast from this NS set of NS managed objects to a set of what you know to be in there using as question mark. And if that in fact is what's in there, it will work. So that's NS set there. One last thing I'm going to show you here before we get back to the slides is this delete rule. You see the delete rule? I'm clicked on tweets here, so we're inspecting tweets. And this delete rule tells you what happens to the pointer to tweets if we deleted this Twitter user. Because if I delete this Twitter user, does that mean I delete all of the Twitter user's tweets? Well, it depends on this delete rule right here. So right now this delete rule is saying nullify, which would mean no, those tweets would stay in the database and their tweeter would be set to nil because their tweeter got deleted. But there is a cascading delete rule, which would say if I delete this thing, then delete everything that it points to. Just go right down the graph and delete everything. So that's what controls what happens when you delete. Now, I'm not going to ask you to even do delete. I guess I might have asked you an extra credit to do delete in assignment 5. Because deletion, you really got to know what you're doing when you can delete things and what kind of delete rules you want. But I just want to let you know that you specify the delete rule right here in the inspector. Okay. Now that you've defined all your entities, attributes, and relationships, what can we do with these things? Well, to do anything with it, we need to get a hold of them in our code, grab onto them, basically. And to do that, we need another important class, NS Managed Object Context. So I told you those things in the database are NS Managed Objects. You need an NS Managed Object Context, which represents a database, to do anything with them, to get any of them, to create any of them, etc. This is the hub around which core data activity turns, as I say there. So how do I get one of these NS Managed Object Contexts? And the answer is you need a persistent container. Woohoo! And you know where to get one of those. You just click Use Core Data, and it's going to appear in your app delegate. You're going to get that lazy var. It's called persistent container, and that is going to be a persistent container. And from that, you can get the context. Now, if you have the lazy var in your app delegate, how the heck do you call that var? How do you get that var? And this is how you do it. Okay? You get a copy of the shared UI application. Now, we haven't talked about this, but your app has this one and only UI application object that represents your application, and you get it by doing UI application.shared. Okay, it's a var, static var in the UI application class. Gives you the shared one. Then you're going to access this var in UI application, which is its delegate. Okay? Now, its delegate is automatically set up for you to be this Swift class app delegate that you see we always put it off in supporting files and get it out of our way, but it's created for you. It's a nice little class. We're going to talk about the application lifecycle and where it fits in a little bit, but for now, all you need to know is you're going to get that delegate, and you want to send persistent container to it to get that var, but of course you have to as it to be the app delegate class first. So this is the code you're going to use, UI application.share.delegate as app delegate, all that in one expression, dot persistent container. Now you're going to get this persistent container. And notice I'm doing as exclamation point. This will crash if my app delegate is not in fact app delegate, but it's already wired up to be that for you when you create a new project, so that should never be a problem. Okay, so now I have this persistent container. I need to get the context out of it. And so the container has an awesome var called viewContext. And the viewContext is an NS-managed object context that's only suitable for use on the main queue. This is in red. You know, whenever you see anything in red on my slides, this means pay attention. It will matter for your homework and in life. But you can only use this view context in the main queue. It's called view context because you use it with your views, okay, your UI views. That's why we call it view context. So why do I make a point about this main queue? Well, the reason I do that is because NS-managed object context is not thread safe. But I'm going to talk to you about how we can do multi-threaded database stuff towards the end of this talk. All right? So now you have this view context, and you can use it to do things. Now, it's so common to be accessing this that this line of code, UI application.share.delegate as exclamation point app delegate parentheses dot, that's kind of a messy line of code. There's as and all these things in there. So a lot of times we'll just create a static version of persistent coordinator in our app, or persistent container in our app delegate. Okay? And we'll just call it the same thing, persistent container, but it's static, and it's just going to return that messy line of code. So now we can get that persistent container with appdelegate.persistentContainer. See what I did there? I just made it easier to get it by making that be a static, a class var. And we can do the same thing with view context. You might create a static called view context. And for the rest of these slides, you can assume I've done this, which is good because typing that long messy thing would make all my slides spill over the edge. So I'm going to use this shorter version as well. And you're welcome to create these static vars in your app delegate if you want to make your code a little cleaner. Now this view context and the persistent coordinator are shared. There's one of them that represents your entire database. So it's perfectly fine to create a single static that does this. By the way, what if you wanted multiple databases? You could even have multiple databases with different schema. Very easy. If you go look at the code for persistent container, in app delegate, you'll see it's only like 4 lines of code. And you could just copy it to create a different persistent container using a different XT_model_D file. Instead of using model or core data example, create another one with a different one. Then you can just go new file, and create another data model. You could even create 2 persistent coordinators with the same model. So they would be separate databases, but have the same model, the same entities, attribute, and relationship. That's perfectly allowed as well. But for everything you're going to do in this class, and really for most apps, you're going to have one big database, and you're going to have this one persistent container that is the container for it. Okay? All right, so now I have a context in my hand, this view context. And what can I do? Well, of course, I can insert objects in the database, I can delete objects from the database, and I can query for objects in the database. So let's talk about all those things. Let's start with insert, because until we insert some data in the database, we can't do any of those other things. And the way you insert an object in the database, or a way to do it, and actually for the next few slides, I'm going to kind of show you the essentials, but we're eventually going to move up to a higher level and access this stuff in a much nicer way. But I'll tell you the basics of it first. So the basic way to put something in the database is with this really interesting method, nsEntityDescription.insert new object for entity name into context. Okay, that's a mouthful. Used to be even more of a mouthful before they renamed it. And you just specify the name of the entity, so tweet or Twitter user, and you give it a context. That's going to be the view context you got from the app delegate, and boom, it's going to create one of these in the database. Now, all of its attributes will be nil. Okay? Although you can inspect the attributes in the data model editor and specify default value. And so it might start out with the default value, but if it doesn't, then they'll start out as nil. Okay? So that's great. I can now create one. And now I need to set those vars to have some value. I need to set the text of the tweet and things like that. And I told you I'm going to do this with value for key and set value for key. So for example, I wanted to set let's say the text. I could just say tweet.set value for key quote text to be a string. Okay. What's really, and you can do dot notation here with value for key path. That's what I'm showing in green right there. You can, if you had a tweet, you could actually set the tweeter's name using this dot notation, set value for key path tweeter.name, and it would go through the tweeter relationship, which is kind of fun. I'm kind of going fast through this because this is a really terrible API. First of all, it's got any in there, so there's no type checking going on here. Okay? You could say set value date for key quote text. All right? And that would be perfectly accepted by Swift. Date is an any, and quote text is a string, but of course that's going to fail miserably at runtime, okay, because the text is a string. So we're not really going to use this API, but this is the underlying basic way that core data is doing this. Yes, the key is just the name of the attribute, and the value is all the things we talked about before. All right. I do have the blue use scalar type there, which is interesting. If the thing you're putting in the database is a float or an int32 or one of these things, it's actually going to be stored in the database as an NS number, which is a class. It's an object, kind of generic holder of numbers. But if you flip on the switch in the inspector in your data modeler for that attribute saying use a scalar type, then it'll make the type be double or int or whatever instead of NS number. So anyway, you had a question? Yeah, so the question is, does set value reject something where the types don't match? And the answer is it can't. It doesn't know the types. The types are any. Okay, as long as it matches any, which everything matches any. So it can't. There's no way for it to have enough information to reject. As long as it matches any, it'll accept that as the type. And then at runtime, it will crash if you try to set a date to be into a string field.
So when it's like when the app terminates, when it calls like save context, do we have to like manually go and remove it, or is it
go and remove what?
Add it to the database?
What do you mean go and remove it? Remove what?
Because didn't you like add it to the database? So it's like the tuple is in our relational database, right?
Yeah, we'll talk about saving in this. So the question is, when the app terminates and it does save context, you can try and save this stuff. We'll talk all about saving in a minute because that's an important piece of this. So anyway, that's the keys and values. Pretty straightforward there. In fact, we're going to talk about saving right now. You're doing a nice lead in. So yeah, all these changes that you make with set value and even insert entity description for entity name into context, whatever that thing is called, all that stuff only happens in memory. Okay? If you want it to actually happen permanently in the database, you need to save it. And you do that by telling the context, like that view context thing, to save with the method save. It couldn't be simpler, except that it can throw. Okay? Save is a method that can throw because maybe there's a problem writing out to the database. And there's many problems that could happen writing out to the database. And you need to look at the documentation and kind of figure out what they all are. But the take-home message here is you do need to save. If you don't save, that stuff's just going to be lost when your app exits or whatever. So you definitely need to save. And especially when we start talking about multi-threaded core data, and one thread is working, that thread needs to save if it wants any of the other threads to see the work that it's done. Okay? So You can use try question mark here, remember, which means try, and if it fails, just return nil and ignore it. You can do that if you don't mind that it didn't save. And the kind of things that can happen saving errors, you could obviously have file system problems, your disk is full or something like that. But you can also have inconsistencies in the database. Maybe you had conflicting data, 2 threads trying to save to the same database and they've tried to write over top of each other, those kind of things. Again, a lot of those problems you're not going to have unless you build a pretty complicated multi-threaded application or something like that. But again, you got to check the documentation. It would take too long for me to go through all of it. Okay, now, as I said, value for key and set value for key, really ugly, no type checking, got these literal strings in there. What we really want to do is be able to set these vars as vars. We just want to have a var called text somewhere that we can set, and of course, we're exactly going to do that. And the way we're going to do that is create a subclass of NSManaged object. Instead of having an NSManaged object in the database and we're doing set value and get value on it, instead we're going to create a subclass of NSManaged object, and it's going to have vars on there for all of the attributes, like text and screen name and all those things. And Xcode will generate all that code for you behind the scenes. You don't have to do any work to make that happen. It's quite simple. So let's look and see how we do that. You do that by inspecting the entity. So here I've chosen tweet, okay, not any of its attributes, but tweet itself. And I want to make it so it generates this magic code. And how do I do that? Well, if you go down in the inspector a little ways, you see it says code gen. See that code gen? That's for generating this code, this magic code. Now, you actually have a couple choices here for the code gen. The default, I believe, is this one, class definition. If you choose this one, it will generate that subclass for you, and it will just work. Okay? You'll be able to access your tweets as a class called tweet with all the vars. Now, this sounds good, and it is good. By the way, if you do this class definition code gen, it will not show up in your navigator. It's all behind the scenes. You never really see this file, this code gen file that generates, okay? So don't look for it there if you put this on class definition. This might even be the default, actually, is to be class definition might be on. But there's other choices in here, and the one we choose the most often is category/extension. By the way, category just is the Objective-C word for extension. Okay, Objective-C has something like extensions called categories, so that's why it says category/extension. But you can think in your mind that this just says extension. And what this is going to do is only generate an extension of your tweet class. You have to actually write the tweet class itself. But it's all going to have only your code in it, or it could be empty if you want. The extension is going to take care of all making the vars, okay, the var magic right there. So let's see how this works. Even when I switch to category extension, again, I don't get that extension showing up in my navigator. It's kind of hidden from you. Here I'm going to add the extension way of doing it for Twitter user too. So both of them, both tweet and Twitter user, I'm going to have extension generated. And why do we like this one? Because a lot of times for our tweet or Twitter user, we want to add our own code. Like it's like in a tweet. Imagine you wanted to add a static method that took data from Twitter and turned it into a tweet in the database. Where would you put that code? Well, a great place to put it would be in a tweet class, if there were such a thing. And so you're, in fact, going to create such a thing. And the extension is going to handle all the var business for you. Okay? If you did choose manual none right here for code gen, meaning don't do any code gen, then you're doing value and set value for key. Okay? Good luck with that. The code's going to be a mess. Okay? So we almost always do it this way with this extension. Also, if we build our app using multiple modules like we have in SmashTag, where we have a framework module and then we have the main module, then you're probably going to want to choose from this pull down here where it says module, current product module. I think if you have a single app that's not modularized like that, you probably don't need to set that. But in a multi-module app, you probably do want to. So since we've chosen here to create only the extension. We obviously need to write the code for the classes tweet and our Twitter user. We have to create those classes ourselves. So how do we do that? Well, just like we create anything, we use file new file. And when we do file new file, this time we are back to saying it's a Cocoa Touch class because NSManageObject is a Cocoa Touch class. We want to make sure we set our superclass to be NSManagedObject. Right? So I'm creating a class called tweet, you see, which is a subclass of NSManagedObject. And it's going to create this for us. See? Class tweet, NSManagedObject, no code in there. That space is for us. We get to write anything we want. The code that does the vars is in that extension, which we don't even see, but I'm going to show it to you in a second here. Notice that I've picked the name of this class, tweet, to be the same as the name of the entity in the database, which you want to do. Okay, it is possible to not do that by inspecting the entity in the data model, but don't do it. Just have the entity be the same name. People reading your code are going to expect this class, this subclass of NSManageObject that represents a tweet entity, to be called tweet. So call it that. Now, we got an error here. Well, I just created this class. How could I possibly have an error? I haven't done anything. How could I have done anything wrong? Well, the problem here is really Xcode has done something wrong. When Xcode created this, it didn't seem to realize that NSManageObject is not in UIKit. You see how it put import UIKit at the top? Really what we need there is import core data. Okay? All the code that you write, anytime you're doing something in core data, you have to import core data. It's a different framework than UIKit, so you must import it everywhere that you're going to use it. Just like we had to import Twitter everywhere we want to use that Twitter framework that I gave you. Okay? So I don't know why Xcode, I think it's just an oversight that Xcode, when you choose NSManageObject as your superclass, you should know, oh, that's in core data, so it should be import core data there. Don't know why it doesn't do that. So here I created one for the Twitter user class. Again, you can put anything you want in there. This is your class. You can do anything you want. All the stuff about the vars is off in the extension somewhere. And in fact, let's go take a look at that extension and what it looks like. Even though it's not going to show up in your navigator, you're probably never going to look at it. I thought I'd show it to you so you understand a little bit what's going on. So this is the extension that's generated for Twitter user. You see that it's an extension of the Twitter user class, right? Remember extensions? And it's got the vars there defined, not just name and screen name, but it's got that relationship var tweets as well, right? And look at the type of tweets. As promised, it's an NS set. It's an optional because it comes out of the database. It's not set, but it's going to get set. And so these are the vars. And I'll talk a little bit about how these vars are actually implemented in a minute, but all the vars are there. There's also some functions down at the bottom. You see those functions? Those are kind of fun. Those are convenience functions for adding and removing tweets from the tweets set, because NSSet is immutable. Okay? It's not var versus let like Swift things. NSSet is kind of old Objective-C way, and NSSet, like NS attributed string, is immutable, cannot be changed. So how can I add any tweets to my database here? Well, you use these functions instead. Add to tweets, remove from tweets, add to tweets, remove from to tweets. There's a pair for doing a single tweet and then adding a whole bunch of tweets or removing a whole bunch of tweets. Okay? So you're definitely going to want those functions for your assignment 5. Okay? Because you're going to have some relationships where you're going to want to add them using these functions. Now it adds those functions for any too many relationship. Anytime you have a too many var like tweets, it's going to add these functions automatically in the extension. It actually put it in its own little extension. This file has 2 extensions in it, okay, both to Twitter user. Any questions about extensions there or any of that? Okay, let's look at tweets extension real quick. A couple other things to look at here that I didn't look in the other one. Notice this static func called fetch request. Okay, put that in your mind. I'm going to talk about that in a few slides. The fetch request is a really cool little static func that will give you something you can use to fetch tweets. And if you call fetch request on Twitter user, you'll get something to fetch Twitter users. And we'll talk all about fetching in a moment here. Notice the type of tweeter. You see the tweeter var? Its type is Twitter user. Because, of course, that's what the tweeter is. We control drag between a tweet and a Twitter user, so that tweeter var is, of course, a Twitter user, not an NS set, because it's a 2-1 relationship. Okay, there's only one Twitter user who is my tweeter. Okay, and what about this @NSManaged? Okay, @NSManaged, I'm just going to say it's magic. It's not really magic. It's essentially something that says to the runtime, hey, when someone accesses this var, core data is going to figure it out for you. And what core data does is when you try to say tweet.created equals some date, it gets trapped at a low level in the runtime, and core data swoops in and does set value for key for you. Okay, same thing if you get the created var, it swoops in and does value for key and gets it that way. Okay, but it's all happening kind of at a low level behind the scenes. So this extension does satisfy the extension limitation where it can't have any storage. All the storage for these vars is in the database. And when you ask for it or when you set it, it's using value for key and set value for key to set it in the database. Now again, it sets it in memory. You have to save it for it to actually go out to the database, but that's what's happening. All right, so now that we have these classes with these vars, we're never going to do value for key and set value for key, ever. We just don't do that. We use these, and I'm going to show you how we do that, what that looks like. So here's some code that creates a tweet and sets its attributes. Okay, so let's look at this piece by piece and see what it does. The first thing is to create a tweet. We don't have to do NS entity description, entity, insert entity for name into context, or whatever that huge, long, terrible thing was. We can just say tweet, parentheses, context. You just say what context, which means what database you want the tweet put in, and it creates a new tweet. Okay, just use a normal initializer for a new thing. So that's super cool. That's one of the coolest features right there, not having to use an NS entity description thing. So no more NS entity description. You will not have to do that. And then here, I'm setting the text to be 140 characters of pure joy, okay? And I don't have to say set value 140 characters of pure joy for key text and have all these literal strings like text in there and this untyped thing. I just say tweet.text equals that. And same thing here with created. Again, it's typed, so we don't even have to worry about the thing. If we tried to say tweet.created equals quote hello, this Swift would say no, created is of type date, so you can't do that. So it finds all of our, it type checks everything, finds all our possible errors. What about relationships? Okay, setting relationships. So here I've created another object, a Twitter user. And again, I just said Twitter user with the context. I'll talk about that argument in just a second, but I told what database I want to create me a Twitter user. And then I set my tweets tweeter equal to that Twitter user. So it's exactly what you would imagine, right? Just set it equal to Joe. And what's interesting about this is that when you set one side of a relationship, the other side gets updated automatically, 100% of the time. This is called maintaining the integrity of the database, okay? And core data always maintains database integrity. So when you change one side of a relationship, it changes the other. So that means, for example, if I say tweet.tweeter equals Joe, that if I went over to the Joe side and say, hey, give me Joe's tweets, and I'm even going to turn it into a Swift kind of set, from an NS set to a set of tweet, because we know that's what tweets are, right? Tweets are a set of tweets. So I'm going to as it to do that. Then I can say, if Joe's tweet contains that tweet, print yes, and of course it is going to print yes. Because when I said tweet.tweeter equals Joe, it automatically got added to Joe's tweets. That makes sense? And same thing the other way. If I added a tweet into Joe's tweets, that tweet's tweeter would automatically be set to be Joe. Okay, both sides will always point to each other. You never have to do anything to make that happen. Yeah, so that's the same. Saying tweet.tweet equals Joe is exactly the same as saying Joe.add to tweets, tweet. Remember, add to tweets was one of those convenience functions it created for us over there. Now, notice the argument I used for the context to create the Twitter user there. I didn't say appdelegate.viewContext. I didn't use that same context var that I had. I said tweet.managedObjectContext. In other words, I found out what database the tweet is in, and I put the Twitter user in the same database. And this is a common way of programming in core data, where when you want to get a context and you already have an object in the database, you ask the object you already have what context to use. And you can see that if I ever change my code to not put this into this context. To put it into another context, at least the Twitter user and the tweet would always be together in whatever that context is. So do you see why I used the tweets managed object context here to create that instead of using the context again? So it would have worked to say context, of course, but I'm just saying there's a paradigm of development here where we're going to try and use the context of related objects so they end up in the same database for sure. Okay? All right. So we can also use dot notation because these are just vars. So when I say tweet.tweeter, I get a Twitter user object. So of course I can say dot name on it and set it equal to Joe Schmo, whatever. Right? Tweet.tweeter.name equals Joe Schmo. All right? No restriction there on those vars. All right. Remember I told you about the scalars. This is that switch I was telling you about before. If you don't do this, then when you say, if you had an int, let's say you had retweet count, which was an int, let's say, here, on something, an int32. If you don't switch this button, then that's going to be an NS number, not an int32. But when you click this switch on, now that var will be of type int32. So you almost always want this for numbers. 99.9% of the time you want to have this switch on. Luckily, it's on by default, so you don't even have to think about it much. But just wanted to let you know about it. All right, so now let's talk about deletion. Okay, now I want to delete something from the database. And that's incredibly easy, almost too easy, because your data is precious. You don't want to be deleting it too easily. But you do that by asking the context to delete the NS-managed object. So you can pass any NS-managed object to this method, delete, and it will delete it from the database. And it could cascade and delete other things as well, depending on what the delete rule is. All right? Most of the time, by default, when it deletes something, other things that point to it get their pointer set to nil. That's the nullify delete rule. Now, when things get deleted from the database, they get sent this message first, prepare for deletion. Okay? And this is a really good method. Again, in here, you don't have to do anything to worry about the other pointers pointing to you. That's all fixed by the delete rule. But what if you had another field in your database? Back to the retweet count example again. Let's say I had an int somewhere in Twitter user which counted the number of retweets that this Twitter user had done. And so if I was deleting a tweet and it happened to be a retweet, then I need to set that to be -1. And here's a perfect place to do it. So tweet, in its prepare for deletion, saying, oh, I'm about to be deleted. I better tell my Twitter user, because I'm a retweet, that he needs to decrement his retweet count. So you see why you would use prepare for deletion? It's a way to kind of update other things in the database as you're leaving the database. All right, so that's it for deletion. Next topic, querying. The most important piece of this whole database thing. It's really a waste of time doing all this stuff if you're not going to query. Okay? If you're not going to make sophisticated requests for the information based on the relationships, etc. So to do a query, the most important thing you need to know is NS fetch request, this class NS fetch request. An NS fetch request encapsulates what you want from the database. So let's talk about NS fetch request and how we build one, and then we'll talk about how we execute one. So when we're building one, there's three important things we need to know. One, what entity are we fetching? Because a fetch request can only fetch one kind of entity. There's no such thing as a fetch request that will give you some tweets and some Twitter users. No. Okay, a fetch always gives you all tweets or all Twitter users. Make sense? So that's the number one thing is we're going to create the fetch request, and it will be a fetch request for a very specific entity, and it will only be able to fetch those entities. The second thing is an array of sort descriptors. And why do we want this? Because when we execute this fetch, it's going to come back as an array. Okay? All the matching tweets or Twitter users will come back in an array. And since it's an array, arrays are not sets. Arrays are ordered. And so we have to specify what order the things are in the array. So we do that with these sort descriptors. And finally, we need to specify, well, what is it that we want? Which tweets do we want? Which Twitter users do we want? And we do that with something called a predicate. Okay, so let's dive in and look at all three of these things. This is what it looks like, kind of top level, to create a fetch request. Okay, you get a fetch request, you set its sort descriptor, and you set its predicate. So look at each of these three parts. So getting the fetch request is easy. We're going to use that little static function that the extension that I talked about made for us called fetch request. Now, this is one of the very few times when Swift cannot infer the type of this return value. Okay, I should put this in red, okay, because it's so rare. Swift can almost always infer things. But it turns out NSManaged object has a fetch request method, and it returns a more generic kind of fetch request. And so when you're getting it, it doesn't quite know which one you want. So when you ask a tweet for its fetch request right here, you have to tell it that you want the one in tweet, not the one from its superclass. All right, so you say let request equal NSFetchRequest. It's a generic type, like array or something like that, right? This is a fetch request only for tweets. So you say NSFetchRequest for tweets equals tweet.fetchRequest, and it knows, of course, that the only one that returns an NSFetchRequest for tweets is the fetch request in that tweet extension. Okay? So now you have a fetch request. This is how you get a fetch request. Couldn't be easier. You just have to remember to do that static typing right there. Okay, now we need the sort descriptor, right? Let's get this array coming back. What order are they going to be? Sort descriptor looks like this. You create it with a key. That is the key, the attribute in the database that you want to sort on. So the screen name or even the text in the tweet or the actual name of the tweet or whatever it's going to be. This right here, sort descriptor, will be a sort descriptor only suitable for fetching Twitter users because screen name is a key in Twitter user, not in tweets. We wouldn't use this sort descriptor in a tweet request. And I say that because on the previous slide I just showed you how to make a fetch request for a tweet. Anyway, that should have been Twitter user. But anyway, so this is a Twitter user sort descriptor. And notice it has ascending or descending, right? That's A to Z or Z to A. And then it has this argument selector. And this one creates some confusion. But really, this selector just says, what method am I going to use to compare items to do the sort? All right? Now, you don't even have to specify the selector if you don't want to. And for almost all data types, numbers, dates, it's going to use a method called compare. Okay? Compare returns something called a comparison result, which is either it's the same, it's greater than, or it's less than. That's what this compare method does. And it's implemented by date, it's implemented by int32, it's implemented by double, it's even implemented by string. Okay? So you could just use compare. But for strings, you want to think a little bit about what kind of comparison do you want. Do you want case insensitive compare? Or you can even use this special compare called localized standard compare. This will compare them so that it sorts just like the Finder on the Mac. And what does the Finder on the Mac do that's different than case insensitive? Well, there's a lot of issues with things like diacritic marks and things in your local language where things sort differently depending on what language you're in, what locale it is. Sometimes you ignore the diacritics, like accent marks. Sometimes they mean something. And so localized standard compare is a special compare for strings that knows how to do that. Okay? And this is very commonly the one we will use for strings. When we're going to show something in our UI, maybe this array of things we're fetching, we're going to put it in the UI, we would want it to be in order, this localized standard compare. You notice that it's an NSString dot method. It's not string.localized standard compare. And that's because this has to be an Objective-C visible method. And so you need the NSString version. So basically you're going to say NSString dot, and you can go look, search for compare in NSString or in string, because string implements them all as well. But you need NSString dot and then the name of the method. And you can search, and there's case insensitive and the standard compare, and then there's just regular compare, et cetera. Now, one other thing about this is that these methods, some of them are special in that it does the compare on the database side. Okay? It's using SQL to do it. See what I'm saying? It's not actually bringing all the data over, calling this method on every string and doing some kind of quick sort or something. It's using super powerful sorting mechanisms that are built into an SQL database. Okay? So in fact, all of the NSString ones will do that. Okay? So they're super duper efficient. Now, if you wanted to use your own compare, though, it's not going to be efficient because it is going to have to bring all the data from the database into your memory so it can run your little method over it. So I strongly recommend against using your own selector here, okay? I would use these standard selectors. If you're going to use your own selector, it's got to be on a pretty small data set because it's not going to be very efficient. Okay? Notice that when we do this fetch request, we don't just give it a sort descriptor. We give it an array of sort descriptors. That's the old sort by last name and then first name, right? So if we have 12 Smiths in there, we'll sort them and the Smiths will be in the right spot, and then all the first names of the Smiths will be in order by that. So we can have as many of these. So it's sort by one thing, subsort by the next thing, subsort by the next thing. Basically, we can break ties with subsequent sorting things. That's why we give it an array of sort descriptors. Everyone understand that? Okay? So that's the fetch request and its sort descriptors. Now the predicate. Okay, the predicate is the guts of saying which tweets do we want, which Twitter users do we want. We create them with kind of an interesting API. It looks a lot like printf from C. Okay, it's NS predicate, format colon, and then a string. And the string is a format string. And again, it looks a lot like printf. So the best way to explain this is probably by example. But the way you're going to learn this is you're going to go read the documentation for NS predicate. You've got to go read that documentation. In its class documentation, there's going to be a link that says creating predicates or something like that. Click on that and go there and learn all the things you can put in this format string, because it's all very specific to doing database queries. But I'll show you some examples so you get an idea of what's going on here. So here's the first one. Let's say I have this search string called foo, and I want to find all these searches that I'm going to do right here are tweet searches. These are predicates for searching for a tweet. So first I'm going to find all the tweets whose text, the actual tweet, the 140 characters of pure joy or whatever, contains case insensitively, that's what square bracket C means, %@. And then %@ is a substitution variable, and I have to give its value at the end, and so I'm substituting search string. Okay, note that I can't say text contains foo. I have to say text contains %@, and then put something at the end there. Okay, so that's an obvious one. I'm searching for all my tweets that contain foo. How about this one? I want all the tweets whose tweeter equals %@. I'm going to put Joe in there as the substitution variable, and were created after some date that I create. See that? I'm using greater than to do that. And I'm doing ampersand for and. You can also use the word and there. Okay, so that's going to be all the tweets created by Joe since that date. You're starting to see the power of being able to query into the database, right? If I had thousands of tweets, it'd be really easy to find the ones since yesterday, for example. I'll show you that in a second here. And then I can also, though, search through dot notation on other fields in other entities. But this tweeter.screen name equals %@ with CS193P, that's still searching for tweets. That's searching for tweets whose tweeter's screen name is CS193P. You see what it's doing there? This is still a tweet predicate. This is not a Twitter user predicate. Okay? So here's a different predicate. This one is for a Twitter user. Okay? So here I'm searching for all the Twitter users who has a tweet whose text contains foo. Okay? So it even knows how to do a pluralistic search right here where you've got tweets.text. That means all the tweets, texts. And it's doing contains. Again, we could do square bracket C if we wanted, foo. So that's a Twitter user search right there. We're looking for the Twitter users who have tweeted anything that includes foo. Again, a powerful search, really easy to express in the predicate. Okay? Question? So the question, does it infer this from the name of the variable? It's not inferring it. It's actually using the name of the attribute, tweets, right there, and the name of the attribute, text, and it's building a SQL statement that will go and do this fetch. Okay, now it's doing all that underneath the covers. We don't care how, but it's doing it. Okay. Yeah, compound predicate. You can build a compound predicate by like an and predicate or an or predicate. You could put or and in the string, or you could create separate predicates and them together by creating an NS compound predicate and predicate with subpredicates. You just give it an array of predicates and it ands them together. Why would you ever want to do this versus just putting and or in there? Well, maybe you're computing what the predicates are based on some, depending on what the user clicked on or something, you're computing it, and so you want to add these things you computed together. All right? There's also function predicates. Now, these are super powerful predicates, and you don't need these for your homework, so don't worry too much about these, but they're cool. You can even say, you have a search like this one, tweets.@count is greater than 5. This is a Twitter user search that finds all the Twitter users who have more than 5 tweets. Okay, so @count is actually running kind of a function in the database to go count the number of tweets that this Twitter user has. So again, you'll see all this when you go look at the NS predicate documentation. It's incredibly powerful. You can see you barely have to type anything in as the format string, and you get these really powerful searches. All right, so let's put it all together now to create our fetch request. Okay, I'm going to create, in this case, a Twitter user fetch request. So I'm saying fetch request, angle bracket Twitter user equals Twitter user.fetch request. Then I'm going to create a time, which is yesterday. It's actually not, it's 24 hours ago. Okay, time interval since now, minus 24 times 60 times 60, that's 24 hours ago. And I'm creating a predicate that says, find me any Twitter users that have a tweet that's created before yesterday. Or since yesterday, I guess. Yes, created is greater than yesterday. So I'm finding all the Twitter users who have created tweets in the last 24 hours. That's what this one does. So any is a special term, okay, that means match any of these things. And these things are tweets that are created since yesterday. And I'm going to sort the result by the actual name, the real name of the Twitter user. So I'm just doing sort descriptor, key of name, ascending true. I'm not specifying a selector, so I'm going to get kind of the default comparison. Okay, that's it. So that's how you create a fetch request. Now, since I have a fetch request, how do I make it go? Give me those tweets. Give me those Twitter users. We do that with the very simple method in context. So we ask the context to do the fetch, and it will go out and return an array of all those things, sorted in the way the fetch request says to sort them. Okay, simple as that. The only thing not so simple, it throws. Okay, just like context save throws, context execute also throws. So you can put it in a try question mark. In that case, if the execute fails, and usually it's going to fail because your predicate is wrong or something, okay? Like your predicate just makes no sense. Then it could fail. If it's going to fail, you're going to get back nil if you do try question mark. Remember, that's what try question mark means. It means try this, and if it fails, give back nil. But if it doesn't fail, then you're going to get an optional array, and that array is going to be empty if it couldn't find anything that matches your request, or it's going to be full of objects, okay? Tweets or Twitter users, an array of tweets or an array of Twitter users. At least that's what it's going to look like to you. It's not quite that. It looks like it. All right, that's the result you're going to get back. So again, super simple querying. Now, you might be a little scared of doing this request. What if it matches a million things, okay? Are you going to get a million tweets back in one request like this? The answer is no, okay? This array that you get back is really super smart array. It doesn't actually bring the data in from the database until you start asking for it. Okay? So until I ask for the a certain Twitter user's information, the Twitter user's name, the Twitter user's screen name, the Twitter user did not get faulted from the database. This is called faulting, okay? And so these objects, you can imagine, they're kind of shells, empty shells, and until you crack open the shell and start looking inside, it doesn't actually get the data for you. And the reason this matters to you is if you go in the debugger or you do a print statement like this one, where you say, for a user in recent tweeters, fetched user whatever, when you print that out, it's not going to print a Twitter user object. It's going to print some kind of faulting shell, okay? Because you haven't actually asked for any of the data inside that thing yet, so it hasn't faulted yet. But if you say, for user in recent Twitters, and say fetch user named, and now you say user.name, now you are faulting this object in. In fact, this for loop would fault all these objects in to memory. Okay, fetch them all because you're asking for the name of every single one. Boom, fault, 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 they're all coming in. Now, it doesn't do it one by one. It faults in batches. It's really high performance, so, don't worry about that. But I just don't want you to be surprised when you go in the debugger and you're like, oh, I printed out this Twitter user and there's no name, there's no screen name. What's going on? Well, it hasn't faulted it in. In fact, the debugger, you could say print user.name, and it would fault it in. Okay, and give it to you. All right, I told you I was going to talk about core data thread safety, so here it is. NSManage object context, the context thing, that thing that you're sending executes to, the things you're hitting save, the things you're using to create tweet subcontext, colon, whatever, that handle on the database is not thread safe. A context can only be used on the queue that it was created on, period. If you passed a context to another queue, like you tried to dispatch off to some global concurrent queue and you passed it the context, or even just passed it a tweet, okay, that's not going to work because that tweet was created on this other context. So in fact, not only the context, but everything you create on that context has to all be done in the same queue. So now you're probably thinking, well, how the heck do I do multi-threading then? Because a database, especially, you can imagine, for example, wanting to load your database off the main queue, because you might be loading lots and lots of things. Now your queries, you're probably going to do those on the main queue because the user's looking at that information. You want it to be highly responsive. Okay, it's probably worth, and core data is super fast, especially with queries, so you could probably do that on the main queue. But loading it up, you probably don't want to do that. All right, so how do we do multi-threading? Well, the way we do multi-threading in core data is each database can have multiple contexts, okay? So the database underneath is multi-threaded. It can have multiple contexts writing to it, okay? Completely different context writing to the same database in different queues even. So it's fully multi-threaded. So that means we had to have a context for every queue. Whatever queue we're going to access the database, we have to have a context in every queue. Now I'm going to show you how to create a context on another queue, so you can do something on another queue in a second here. But first I want to talk about this important method in context called perform block. Okay? Perform block just takes a closure that takes no arguments, returns no arguments, and it will ensure, this is an insurance method, it will ensure that everything inside that closure happens on the right queue for that context. Okay, so don't get confused, this method does not dispatch, cause background threading. This is just making sure that that closure executes on the right queue. Okay, so this is a way that you can kind of be safe. And some might argue you should put perform block around every single call to every core data thing you ever do, because that will assure that you'll never have a problem where you're accessing the context not on its queue. Okay, it accidentally, you got some bad code. Now, that might be a little bit of overkill, especially if you're mostly using the main queue anyway, and maybe you only use background queues for this tiny little bit of processing on the side. It's not like you have tons of contexts in lots of different queues all going at each other. So it might be overkill, but if you're doing anything where you truly have multiple contexts on multiple queues and they're accessing things, this is a good way to be safe. Okay, so all this does is it makes it so you are safe. The code inside that block will be executed on the proper queue for that context. Even if it has to dispatch, it will do it if it has to. If it doesn't have to dispatch, if you're on the right queue, it'll just execute it, fine. But if you're on the wrong queue right now and you execute this, it will dispatch it to the right queue. There's also perform block and wait, which will get it on the right queue and wait till it's done and then continue in your queue. Okay? But this doesn't really talk about how do I get another context in a different thread, right? I want to do some code on another thread. Where do I get a context? The only context I know how to get right now is view context. That's the main queue's context. That's the only way I can get. Okay, well, you're going to use this really cool method in persistent container. This is new in iOS 10 and really cool method, super cool. Makes it really easy to do background processing with core data. It's called perform background task. Remember, this is a function on persistent coordinated, that thing you get from the app delegate. And this takes a closure. This closure has one argument. The argument is a context, and that context is appropriate for use on this other thread that this is going to create for you. So this perform background task finds another queue, not the main queue, some other queue, and it creates a context in that other queue, and it executes your closure on that other queue in the background. Okay? Now, it's a convenience method, so if you really needed to control the quality of service, for example, of the queue and all that, okay, well, you can't use this, but 99.99% of the time, whatever quality of service that queue is getting is the right one for core data, because core data knows its business. So you're going to do it. Now, inside this closure, a couple of things really be careful of. One, never use view context in here. Do you see why that would be horrendously bad to use view context inside this closure? Because this closure, by definition, is not executing on the main queue. By definition, this closure is on a separate queue, on a background queue. That's the whole point of this thing, is to put this thing on another queue. So never use view context in there. That's why it's in red. Okay? The second thing is, don't forget to save this context. If you do a whole bunch of stuff in here and you don't save, you just did it for nothing because you did it in memory, and then this block went away. You're never going to get that context back again. That data is lost. It's just all going to leave the heap, and nothing ever happens. Never going to get committed to the database. So don't forget to save before you leave. Now, when you save, it will push it down to the database, and your other contexts, like your view context, will see it. Okay? And so these two contexts, the one that's happening on this background task and your view context, they're working on the same database. So when this one saves, boom, this guy's going to start seeing those changes. I'm going to talk a little bit about how we react to seeing those changes in a minute here. Okay, so everyone understand this? Because you're going to have to do this in assignment 5. Okay, I'm going to want you to do all your loading off the main queue and all your fetching on the main queue. All right. Core data is huge. It's huge. There's not really, I can't cover it all. It's got optimistic locking. For those of you who know about database, it's got optimistic locking and all that database stuff. It has full undo redo, which is incredible. It obviously knows how to roll back unsaved changes. Okay, if you have changes in the memory and you want to roll some of them back, you can do that before you save. It knows about staleness, like if I make a fetch, how long before I really want to fetch it again because I don't trust that the data hasn't changed, right? How long does it take for the data to get stale? And a lot of other things in core data. So I can't cover it all, just not enough time to do that because I still have to talk about a whole nother topic about core data here. But you'll want to check the documentation. You won't need anything else of this stuff to do your homeworks, of course. I'm just trying to get you started with this. But you need to know that this stuff is in there so that one day when you go out and do some significant iOS database stuff, you'll know that these features are out there. All right, the next topic here is core data and UI table view. As you can imagine, this is a marriage made in heaven. Okay? Because you got this database, got all these big data sets in there, and what is the UI we use to show big data sets in iOS? UI table view. Okay, UI table view is great at showing arbitrarily large data sets in arbitrary UIs, right? We can do custom table view cell, we can do any kind of UI we want. So this is so common that Apple has invented this very important class called NS-fetched results controller. This is not a view controller, okay? This is a controller that controls core data and UI table view talking together, but it's not NS-fetch results view controller, okay? And all this NS-fetch results controller does is it hooks up an NS-fetch request that you create to a UI table view. And it hooks them up in such a strong way that if anything changes in the database that would cause that fetch request to return different results, it updates the table automatically. You don't have to do anything. So this is an active, live hookup between the NS-fetch request and the table view. Okay? This is even if some other context is changing the data, it doesn't matter. It's always keeping that table view up to date. So I'm going to talk about how we do this, how we use an NS-fetch results controller. I'm even going to provide you some kind of free code to do some of it. You'll have to type in a little bit of the rest of it, but it's pretty easy to do. Okay, so how fundamentally does NS-fetch results controller work? Two ways. One, it has a delegate, okay? And that delegate you set to be your UI table view controller. And whenever the fetch results controller sees something happening in the database that would affect that fetch request, it tells the table view controller, hey, do this, add this row, add a section, reload this row, whatever. It uses UI table view primitives to update the table. Okay, and I'm going to give you the code that does that part of it, that implements the NSFetch results controller's delegate. Okay, so that's one way it does it. The other way that the NSFetch results controller works is that it provides implementation for all of your UI table view data source methods, right? Because the contents of your table are coming out of the database, so NSFetch results controller lets you, all of them, how many sections, how many rows in section, all that stuff. In fact, this is what it looks like. This is the implementation that you're going to put in to your controller when you have a fetch results controller. The first thing you're going to do is you're going to create a fetch results controller, and I'm going to show you how to do that in a moment. And so you're always going to have a var called fetch results controller, and it's going to be of type NSFetch results controller. And when you have that var, now you can implement your sections, number of sections in table view by saying return fetch results controller .sections.count. Okay, and those are a lot of optionals in there, so you'll default to one section. And then to get the number of rows in a section, you're just going to say, you're going to get the sections first by saying fetch results controller.sections. And as long as you have some sections, section greater than 0, section count greater than 0, then you're going to return the sections in that section that's passed to you, number of objects. Okay, so that code, that's it. That's all of those two methods. That's the entire implementation if you're using a fetch results controller. Okay? And then, of course, there's self-row at. Okay, you got to implement that. That one, too, you're going to use fetch results controller. And the most important thing about self-row at is you need to know what's at that row. Which thing in my database is at that row in that section in my table. And you get that by asking the fetch results controller with this method, object at index path. So you just say fetch results controller, give me the object. And that object is going to be a tweet or a Twitter user or whatever, some entity. Give me an object at the index path that self-row at index path is asking me for. So now I have the Twitter user or the tweet. I can easily load up my UI. You know, pass it off to my custom UI table view cell, or if I have a subtitle cell, just take a couple of things out of there and put it into the text label and the detailed text label. You see what I'm saying? But you can see that the fetch results controller, that code in yellow right there in the middle of self-row at index path, that's doing all the work to figure out what tweet or what Twitter user is at this row in the table. Okay, so the code on the last slide and the code on this slide, you'll have to type that code in anytime you're using an NSFetch results controller. Now, on the previous slide, one of the things was var fetch results controller equals something. So now let's talk about how we create a fetch results controller. Okay, so this is what the initializer for NSFetch results controller looks like here. It takes a request, a context, obviously, got to know what database we're fetching in. And then it's got a section name key path. That section name key path is the var in that entity whose value is a string, which is the title of the section it's in. Okay, that's how you do sections with fetch result controller. You just have to, and you might have to invent this or even calculate this, but all of your tweets or all your Twitter users, if they're going to be in sections, they all have to have a var, which is a string, which is the section they're in. Okay, the name of the section they're in. And as long as they have that, then the fetch results controller will make the sections and put them all in the right section. And we'll talk about cache name in a second here. So we have to create a fetch request to put in here. So here's an example of creating a fetch request for tweets, right? So you recognize that first line there, or creating a fetch request for tweets. And I'm going to sort by when the tweets were created, okay, when the tweet was tweeted out. And I'm going to look for all the tweets whose tweeter's name equals some name, the name. Okay? So it's going to get all those tweets, and I'm going to set that request as the first argument there to NSFetch results controller. By the way, notice NSFetch result controller is also a generic type. An NSFetch result controller can only control fetches for a certain type. So you have to say what type, okay? What type of entity that your fetch result is controlling. And this is the same type of things that are in the rows of your table. Now that cache name at the bottom is interesting. That is actually going to permanently cache the results. In other words, it's going to get the results out of the database and store on disk the result in some internal format. And that's cool, and that storage, by the way, if you quit your app and come back, it'll still use that cache. So it's quite efficient. But you have to be a little bit careful. You cannot change anything about your request. As soon as you change anything about your request, like the name, the tweeter.name that you're searching for, or what you're sorting by, or anything, now that cache is invalid, and you'll have to invalidate that cache. Okay, and there's some API in there for doing that. You can pass nil there if you don't want to do the caching, which for most reasonable sized data sets, perfectly fine. You don't really need the caching. But I just want to emphasize that if you change your request, your cache is now invalid. And about that section key thing, something to be careful about there too, is that whatever your sort descriptors say that your rows would sort in, that has to be exactly the same order that your sections would sort in. Okay, in other words, the fetch result controller doesn't know how to move things around because they sort out of order of their sections. That's why a lot of times when we're doing sections, the first sort descriptor will be sort by the section key name var, right? And then the second one will be sort by what we really want to sort by. Because we have to make sure that our entire table is sorted in section order. You see why? Because otherwise it's just weird. Things would all be in the wrong places. So key that says which attribute is a section name has to sort in the same order as your sort descriptors. Okay? Now, I told you that NSFetchResultsController watches core data. It sees changes happening in there and it updates it, and it does that with its delegate. Okay? Its delegate wants to be the table view controller rather, because it's going to tell the table view controller, and it sends messages like this. So this is a typical NSFetchResultsController delegate method. Controller did change add index path for change type, and here's the new index path. Okay, and these change types might be deleted or inserted or modified or whatever. Now, you have to put the code in there that would call the right methods on the table view to get the sections inserted or deleted or rows added or whatever. But I'm going to give you that code for free. Okay, in the demo that I'm going to do on Wednesday, I'm going to have a class called FetchedResultsTableViewController, which is going to be a class, and you can make that to be the superclass of your UI table view controller, and you'll just inherit this implementation of the delegate. Okay? Yes, that's what I just said. Okay, so when you're using core data and UI table view, the things to remember are you're going to subclass fetched results table view controller, the thing I'm going to give you so that you implement NSFetchResultsController delegate. You're going to add a var to your UI table view controller called FetchResultsController, and you're going to set its value to be an NSFetchResultsController with the fetch request that you want, okay, that you want to populate your table. Then you're going to implement your UI table view data source methods using FetchedResultsController var methods, just like I showed you on the slides. Character for character, you can use the exact same things that are on the slide. Okay, and then it's all going to magically work. All you'll have to do is inside yourself a row and index path. You'll have the object, the tweet or the Twitter user. You just got to load up your UI. After you have all this set up, then you can proceed to using the fetch results controller in your table view controller. First thing you have to do is perform fetch on the fetch results controller. That will cause it to go out and do your NSFetch request basically. It's not going to pull all the data over, but it's going to basically do the same thing as if you had executed the fetch request yourself. And then you're going to want to do table view reload data, and that's because you want all of your UI table view data source methods to be called, and you know that we've implemented all of them in terms of our fetch results controller as shown on the previous slides there. And the only other thing you want to remember to do is set your fetch results controller's delegate to be yourself. And again, we use that fetch results table view controller code that added the delegate methods for the fetch results controller to our UI table view controller. And so we can do all the things that is necessary to be a fetch results controller delegate. And what that buys you is that anytime anything in the database changes, that would affect the NSFetch request that you wired up to your fetch results controller, then it will use that delegate to ask the table view to update the rows or sections, whatever happened to change. So let me talk a little bit about what's coming up here. On Wednesday, I'm going to do a big demo that shows you all of this stuff, as usual. Assignment 5 is going out on Wednesday. It'll be due the next Wednesday. It's going to be to add core data stuff to your smash tag. On Friday, very relevant section, it's using CloudKit to do a database. Okay? Now, core data and CloudKit, what are they? How are they related? Well, core data is for doing things that you would do with a relational database, these powerful queries and searches and things like that. CloudKit is, what if you wanted to have a database on the network, in the cloud? Okay? A network that's being shared between multiple people or even by a single person on multiple of their devices or whatever. So they're quite different in the way they approach things. In core data, we do the schema using this visual mapper. In CloudKit, it's essentially schema on the fly. As you start saving vars, it starts making this schema up for you. So it's a very different kind of way of thinking about it. You don't think of it from a schema design point in advance. It's kind of more organic as you go. And also you don't have to, kind of create this whole schema up front and describe it. You can describe it as you use it, essentially. So it's a very interesting comparison between the two. I wish I had time to do CloudKit. Last quarter I had extra lectures. I was able to do CloudKit as a full lecture, but we'll have to do it as a Friday section this week, so don't miss that. Next Monday is a holiday. So no lecture, and then next Wednesday I'm going to go over your requirements for the final project, what you're required to do, and I'm also going to have a lecture as well on auto layout. We'll finally get to auto layout and how to do that auto layout stuff. Okay, that's it. I just wanted to show you that, and I will see you all on Wednesday.
For more, please visit us at stanford.edu.